Now that we have a better understanding of the WRSPM model, maybe sort of a rough understanding of it, let's jump into a couple of examples and sort of further explain each of these areas so that we're all on the same page here and we could actually maybe implement this in if we ever had to do a requirements document. So let's jump into each one of the categories, and I just want to sort of define them a little bit. We have the world, and like I said, the world is basically the assumptions about what we are developing. They can be something that is very, very basic, like electricity is provided, or they can be something pretty not basic. For example, with a car, it might be that humans know how to drive cars, or that humans know how to use a pedal and a braking system. That would be an assumption that we need to know, because if we're implementing a new system, maybe we need to add a tutorial to it. Maybe we're assuming too much from the user, and that's going to make our product fail because we don't actually spend any time developing a system or a tutorial. Maybe that needs to be a requirement. A proper tutorial that is tested is presented to the user. That's very important for new software that's decently complex. If you don't have a good set of tutorials, even if it could do amazing things, no one uses it. So then, the first one is the world, the assumptions about what we are developing. The next one are the requirements, defining our problem in generic, easy to understand terms. We need to know what our problem is. We could say we need an automated teller machine. We could say we needed to get money by not going to the bank. That's a great overview problem, but now we need to define what that actually means. Does it mean we need to install people around the city that we can go up to and talk to get money? Does it mean we want to make it automated? Does it mean that we want to have it, extremely secure, or maybe we want to make use of access more important? We need to define the problem. What's the problem? What solution do we think is best to solve the problem? Specifications is the next step of it. We are defining the more technical details of the interface we're building. So we're actually defining that interface where with the specifications, we have this sort of problem defined. We know what the problem is. We know what the assumptions are. And now we're kind of looking at how do we connect the user with the program? What's the way that we do that? What technologies should we have to use? Like, what technologies do we have to use? What are some of the more technical details about how that all works? Then we get to the program, which is just the code, frameworks, and development process. The program you could sort of define as the rest of this course, going over to the design documents, going over the actual coding aspects, the maintenance of it, the ways that you can develop it. That's sort of the program aspect. And then the machine is the physical hardware we're running on. At some point, if we're building a new piece of technology like an ATM, we might actually have to send it to a manufacturer and an electrical engineer to actually put the inner workings of this thing together. Otherwise, we just have this program that would be kind of cool, but there's nothing to run it on. So we need to understand the machine as well. Is there existing technology out there, or do we have to develop that technology ourselves? So let's go over a little bit of an example here. So what we have is a smartphone photo printing station. We've seen these at Walmart. Maybe if you haven't seen them, I'll describe it to you a little bit. It's basically like an ATM, except it's a little bit different. You have this sort of machine here, and you can go up and you can either insert a USB drive into like a little port, or you can connect via Bluetooth with your smartphone. And basically what you do is you transfer photos onto the machine. It's got this big interface with maybe like a keypad or buttons over here. And when the photos go on there, you edit them, and then at the end of it, it actually prints out the photos at the bottom almost in real time. So this allows you to, if you ever went on a vacation, you took a bunch of photos on your phone, you can go up there, you can pay. There's usually a pay slot here, like with money or with a credit card. You pay, you get the photos, and you're good to go. So that's the machine we're talking about here. Now, I would strongly recommend you pause the video right here and just go through this. I'm not talking you need to define this entire thing. I mean, that would take a team maybe 4 or 5 days to be able to figure out every little idea of what this needs to do. I'm talking go through each of these and put down a couple of things. What are some of the assumptions we have to make? What's the problem here that we're trying to assess? What should the user be able to do? What should the machine be able to do? What are some of the specifications? How should the machine contact things? The program and the machine, I'll give you a hint. The machine is just this, and the program is the software we're developing for it. So you don't really need to focus on that. What we're really focusing on is the first 3 here. So pause it, go over that. And like I said, I strongly recommend this, and then I'll go over my answers too. So I've hoped you paused it and you went over your answers. Again, I can't stress this enough. The more that you put into the course, the more you're going to get out. So please just, if you want to learn as much as possible, just do a little bit, and it'll help you a lot because you can actually sort of start implementing this thing. It'll make you remember it a lot better. Anyway, let's jump into this. So the world, what assumptions do we need to make? Well, some of the assumptions that I came up with is some very basic and some things that we might take for granted. So people have a standardized photo formats to print. That's very important. Imagine if there were no standards, or if people were coming up with really, really random ones. Maybe every single iPhone or every single phone had a different way of storing photos. There'd be no way to create this. We could not have a system that decodes, 800 types of photos. It just wouldn't work. So we're making the assumption that there are very standard photo formats to print from. People will be able to read the prompts and tutorial. Humans are basically literate. That's kind of what this comes out to, is that it'll be in a language that people can read and understand. If you went to a more illiterate part of the world, maybe somewhere that there's not a lot of education or reading knowledge, maybe that's a problem for you. Maybe there's some other way that you can implement this with pictures or something that would help them better. Now, gladly, severely illiterate parts of the world are disappearing with further education, but that's something you might want to keep in the back of your head. The next one is stores will refill the materials. We're assuming that someone is going to go into this and refill the inks and the paper and stuff like that. We're assuming that we're going to put these in stores where people actually do that. Otherwise, we'd have to come up with some solution and distribution network to make sure that these are always refilled. So that's a good assumption. That's something that we would actually need to make sure, is it a proper assumption, or will we need to develop something like that? People have debit cards that work with standard debit card tech, or in this credit cards or any card technology, or money in that case. There's going to be a common currency that we can use on this machine that will work. There will be readily available electricity. That's important. Without electricity, this machine wouldn't work. And there will be available internet. Maybe this machine needs to contact servers. Maybe it doesn't have the hardware on it to do the photo edits and actually sends to a server. Server does the photo edits, and then it sends the data back. That's actually pretty common nowadays. So in that situation, maybe we need internet. And if we're in the back country, that might not work. We might not have available internet there. And we might either have to put in a secondary little bit of processing power in this, just in case it doesn't have internet. It can try to do it here. It'll just take a little while, or maybe there's other solutions we can come up with. But that's an important assumption to recognize. Next part are the requirements. What is the thing supposed to do? So it's a user can connect a smartphone to the system. And if you notice, maybe you want to go over the requirements first before you jump into the world. Maybe you want to sort of define the problem and then understand, sort of work out from that and see what are some of the assumptions I made when making the requirements. That might be a good step too. These things can be done in many, many different ways, just some ideas here. Anyway, requirements. The user can connect a smartphone to the system. The smartphone can transfer pictures over. User can edit photos. The photos can be printed out by a machine, and the users can pay for the service. In general, if you're ever in doubt about requirements, just go over a use case, basically, a way of using the machine. If you walked up to this machine, how would you want it to use it, and how would you want things to interact? That's a great way to start with requirements. Every step, just write it down, and then you can sort of build from there. The next part, specifications. So then now we have this sort of this idea here of some of the requirements. Now we go into a little bit more of the nitty-gritty. How do we connect to it? Well, Bluetooth technology, so a smartphone can connect. That's the most popular way of connecting, so Bluetooth would be a good idea. And then we need a proper Bluetooth transfer protocol to be installed and to make the transaction secured so that no one else can sort of jump in there. We need a proper, or the system will have an editing suite for manipulating photo data. That's important. We need to sort of define our editing suite. Do we want to buy it from someone else? Do we want to design it ourselves? The system will use encryption and chip technology to contact financial servers. That's a great thing to know. How's it going to contact the banks? How's it going to use it? We're using this encryption and this chip technology, so we're specifying the exact way that the financial transactions are going to take place. And then the system will have standard printing device for printing photos. So there's going to be a way to print the photos out. We might be able to define that even more in depth once we start developing it. And then finally we have the program, which I said is just system code, and then the machine, which is just the system specs, the RAM, the processor, etc. Overall though, this is sort of what you do with the world model. This took me maybe 10 minutes. We actually have a sort of a blueprint for what we want to do with this thing. We have a general idea. No one's going all over the place with how it should be built. everyone could get on the same page and we could present this and work this out even further. We could really start going through these things and actually develop like a little bit of documentation, maybe like a 20-page thing defining the problem, defining how we want to solve the problem, defining the specifications of the technology needing, and maybe even the system specifications of what it would be. From that, we could develop a budget. We could develop what teams need to be on it. It's a great starting point, and this is all very important for requirements. Defining our problem, getting them set, and then getting ready to move on to the next phases like design and actually coding the thing.